Okay, in this video I will tell you the how to find finding out the effective diameter by using the 3-wire method. Okay, in this method V piece is used for measuring the minor diameter. So measuring the minor diameter, are replaced by, here in this method the V piece used for measuring the minor diameter are replaced by steel wire, hardened steel wires to sustain wear and tear in use. Okay, this three wire method is most accurate method of measurement of the pitch diameter. Okay, in this case 3 wire of known diameter are used. 1 wire is kept on one side and 2 wires on the other side, that I will show it in the figure. That I will show it in the figure. This is screw thread. Now drawn by hardened steel wire. Micrometer anvil. In this one we are drawing axis. Effective dia. This is capital E. The anvil from that is H, and here from bottom to this bottom line, the distance is y, the diameter under y, that is minimum, and capital H is diameter under, this is maximum, this point. You can call it as a diameter over the wire. This is the diameter under the wire. This is over the wire, this is under the wire. Now you can call it as a figure number A. Now in the figure number B, we have to draw on threads, only this part we have to draw here. Center, this is the effective diameter line E. Here this is the line, effective line E. This is under the wire line, under the wire Y. From here to here, from under the line to the top, we can call it as a diameter D, and a line joining the flank on both sides. One is L, center is R. You can call it as a N, G, that is another G, I, K, that is the pitch. That is the pitch value P, and this is theta by 2, and this angle represent a flank angle, we can call it as a what, theta by 2, and this is the distance M, capital M, and this is the pitch P, and this is the M. now we have to find out what is the Q and Q, G and value, that is theta by 2. This is the figure number B. Now I will write out another two figures. We are considering one figure, that is OLG, that is theta by 2, that is D by 2, and another one figure, this is figure number C, and another one N I K, as mentioned here, theta by 2, here N I K, here this is OLG, OLG, one figure here we have written in the figure number C, and NIK we have written here the figure number D, that is pitch P by 2. Pitch, the distance is what? Pitch P by 2. Overall pitch is what? P. Here we have taken only this triangle, that is P by 2, that is angle 90 degree angle theta, and the distance is what? M. We have taken it as a M. Now we will find out the value of the pitch diameter. Initially it will contain sin theta by 2 sin theta by 2, that is equal to OL divided by OG. Therefore OG is equal to OL divided by sin theta by 2, where OL is equal to D by 2. As we know, OL is equal to D by 2. Therefore OG is equal to D by 2 into 1 divided by sin theta by 2, that is equal to D divided by 2 sin theta by 2. This is the value of the OG. Call this as equation number 1. Call this as equation number 1. Now similarly consider triangle NIK. In the figure, in this triangle NIK, tan theta by 2 is equal to IK by IN. Therefore IN is equal to IK divided by tan theta by 2. So from the figure B, IN is equal to M, we have represented M, and IK is equal to P by 2. I will show it here once again. I and N is equal to M, and I and K is equal to P by 2. So therefore M is equal to P by 2 into 1 divided by tan theta by 2, that is equal to P divided by 2 tan theta by 2. Call this as equation number 2. So from the figure, another figure, from the figure B, again RG is equal to what? M by 2, that is equal to P divided by 2 into 2 4 tan theta by 2. Call this as equation number 3. Again OG is equal to find out the value of at the end we have to find out the value of OR. So OG is equal to OR plus RG. Therefore OR is equal to OG minus RG. So that is equal to OG value also we have found out already, 2 sin theta by 2 minus P 4 tan theta by 2. So this is the value of the OR. Finally from figure A and B, so H is equal to, this is very important, H is equal to E plus 2 times of OR plus 2 times of OQ. For the both side we have taken it as a 2 times, so we have to substitute the value of OR and OQ. So E plus 2 into d of 2 sin theta by 2 minus P divided by 4 tan theta by 2 plus 2 OQ means what? D by 2 to D by 2. So finally H is equal to, will get final value H is equal to E plus D into 2 and 2 will get cancelled, 1 divided by sin theta by 2 plus 1 minus P divided by 2 tan theta by 2. So call this as equation number 4. Question number 4. Now, and finally we'll, for this equation, okay, for this equation we have to show it in terms of metric thread. In metric thread, theta is equal to 60 degree and depth of the thread is equal to 0.6495 into P. This is the depth of the thread. So by keeping this in mind, effector D is equal to what? Capital D minus, so sorry, 0.6495 of P. Substitute that in the equation number 4, that is in this equation we have to substitute where E is equal to value. So finally H is equal to, you will get H is equal to D plus 3D minus 1.5155 of P. H value. The same formula if you are apply for the Whitworth method, Whitworth thread, not method, Whitworth thread, where depth of the thread is equal to 0.64 of P and theta is equal to 55 degree, where E is equal to D minus 0.64 of P. Substitute the same in the equation number 4. We will get H is equal to D plus 3.1656 of D minus 1.6 of P. This is the two different values by using the metric and the metric thread and the Whitworth thread. So H represent what? This is the diameter over the wire, that is maximum, as shown in the figure here, H value. So this is with respect to the, we'll discuss with respect to metric thread and the Whitworth thread. So this is about the 3-wire method. In the next video we'll come to know the we'll discuss the best wire size method. This is very important derivation. Compulsory they will ask for 10 marks. Okay, thank you.